Let me apologize for the interruption. I had it unmuted
don't
because
worry.
Gabriel
Apologize
dropped out.
us for our bad English.
Well, when Gabriel left and he came back in, I wanted to let him unmute himself, and so that was why I had it disabled, but it backfired on me. So so in terms of questions, actually I've been going through chat. Let me ask David Mathis. David had a bunch of questions. David, do you want to go?
Yeah, sure. I'll go. I got to find my list of questions.
Yeah, you had several, and that was why that was why I wanted to start with you.
I didn't get to see a picture. I came in about 5 minutes late, so I didn't see all the test instruments set up. It looked to me like you had made great accomplishment with whatever you had. And I presume you're doing this at home?
Yes, that was Emilio Laureti's home.
Okay.
He actually had a lab, but there has been an earthquake at, maybe you have heard the Amatrice earthquake in the middle of Italy. And this earthquake destroyed his lab.
Oh, okay.
So he has to move all the instruments to his home.
From just the experiment, great setup. It's great, and it actually, the protection, I think you need a little more protection, maybe a radiation badge, who knows? Okay.
Yeah, thank you.
Have you looked at the sources of weight reduction? Is it a single effect, or do you think it might be multiple effects?
This is a question for Emilio. I don't remember if I said that, but I am not a physicist, so I can't reply to many questions.
That's fine.
Oh, if I could jump in really quick, I should mention, so Emilio Laureti is the primary. I believe he's the primary inventor, and he's really been in charge of this project. English is not a native language for him, so he's actually with us, and if he feels comfortable speaking, I would love to have him speak and answer questions. But Sergio and Gabriel they communicate much more fluently in English, so they did the presentation.
Okay. So, what percentage weight loss has been achieved?
Sorry, this is not weight loss. This is a weight increase. This is the direct measurement of thrust on a scale. So it's like the prototype was pushing on the scale, or trying to lift off from the scale.
Okay.
So this is not anti-gravity, let's say.
So then what is the thrust to mass ratio?
Nice question. I try to ask to Emilio if I can find him around the participant. No, he's not here. Okay, here. I'm asking.
Okay, that might take a little bit. Another question that I have is this a time-dependent operation? To me, it appears to be, it's not an on-off operation. There's some sort of charging going on. You mentioned that if you turn it on too quickly, that it shorts. Is that a, can you explain what you mean by shorting?
The basic concept is that the thrust increase over time.
Okay, so it's a time-dependent operation.
Mm-hmm.
All right. Do you know what that?
The more the times, the PNN is feed it, the more thrust it has.
Okay.
The thrust depends on the time.
Have you
More time, more thrust.
Have you tried to do curve fitting for the charging or discharging, or the thrust increase or the thrust decrease once you turn the switch off?
Can you
Is it a linear increase, or is it a parabolic increase, or is it
I don't know if it's the correct curve, but it's not. It seems to not be linear.
Okay.
Okay, that's fair enough.
It's
Okay,
not properly linear.
All right, gentlemen, thank you. Tim?
One thing I'd like to add is that I forgot to mention before is that some people have made an observation about PNN, and they have said it works by photon recoil. Emilio asked us to underline that this is not the case. For Laureti, it works only through the interaction of Lorentz forces.
Okay, so, all right. So have you measured the magnetic portion of the Lorentz force?
Those are questions for Emilio, but unfortunately,
Do you have a trimeter, or do you have a magnetometer in your instrumentation?
I know he has a field detector, but we haven't got. There is the problem that they're too big to be placed nearby the dipole, and the measurements we require are nearby the vertex of the dipole, and so it is difficult to measure that part of the dipole.
Okay. All right, Tim. Gentlemen, thank you.
To you.
If you have question, I think you can directly write those to Emilio, either by chat or I show you again the address email. I share you the email address. Just a second.
I just write the email address of Emilio on the chat.
Okay.
Hello, Sergio.
Yes.
Hi, can you hear me?
Yes, I can.
Hi, my name is Eric Hermanson. I had just a couple quick questions. I missed the first 10 or 15 minutes, so I apologize if I'm re-asking. And so I'm looking at the force vectors, and seems like if you would make it a diamond shape and have a back end on it, wouldn't that push? Wouldn't the back thrusters, if you reverse the phase in the back two thrusters, wouldn't they all result in a forward push?
You mean changing? You'd like to change the shape of the thruster, am I right? I have understood right.
Yes, make it a. What would happen if you made it a diamond shape? Would the back the back thrust, the back forces would cancel, but if you reverse the current, would the in the back part of the diamond, would that add to the front thrust? You see what I'm saying? Instead of having it a triangle,
okay,
it would be. What if you made it a diamond shape?
Like those in play cards, the symbol in play cards, the seed in play cards. You mean that kind of shape?
A diamond, yeah.
Yeah, yeah, the
Okay,
card,
okay.
yeah.
Okay. I don't know if Emilio ever tested this kind of shape. However, he said once that there are, he found 11 possible shape for this thruster. Another shape that has been experimented is an semicircle, about 1/6 circumference.
Okay. I'm just talking about the back part of the diamond where you rotate the force vectors so they're also pointing in the same direction. I don't know. I don't know if that would work. Have you tried running this underwater?
No, this has never been tried.
Because it would definitely cool the mechanism, and I don't know how the fields the fields are would create currents in the water and things like that, but I don't know.
Yes,
you might want to try
or oil, for example. This is we are working on some kind of cooling system. For the moment, it's only passive cooling. However, we have taken into consideration some other cooling system, water or oil, that they might work. But at the moment, Laureti wanted to keep the thruster as clear as possible without anything on it, paradoxically to avoid other things that might break.
Now, if I could jump in really quick, and Eric, thank you. So I spotlighted Emilio's video. Hopefully you can all see that. He's demonstrating a device. And Sergio, if you'd like, feel free to describe this. It looks like this is SV432. So
it's, yes, F432.
F432, I'm sorry.
Don't worry. Okay, yes, here we are looking at the thruster. This is the frame that keeps keep in shape. Move it. Give the shape to the vehicle and keeps it in shape. This is another thruster. This is an improvement of that thruster. This was made by Emilio after some criticism about the testing procedure, because some technicians say that the external power might lead to measurement errors. So he created this new thruster. This part is showing is the signal generator part, and behind this side, on the other side, there are the batteries. So in this thruster, it is a single piece all together with the batteries, and the whole structure is put on the ballistic pendulum for testing. Here you can see this is the signal generator. This is the amplifier part. And then this is the amplifier part. And above this, there is the attachment for the F432 thruster. So basically, this is an add-on to make it independent from external power sources. I think I can show you some picture.
Little cart.
Little cart, yes.
Moafeg, pre-amplifier. Amplifier. Thermal dissipazione, this.
Thermal dissipation, yes.
Ah. In this part, this is
this should be
remote control radiator.
Yes, this thruster has,
two lithium batteries here. The prototype is in this part. A moment.
video we can see it.
Aspetta, moment.
Oh, okay, okay.
In this part, prototype, this. On to scale, bilancia.
Yes, scale.
This is a remote control on off. Not more. I have a problem.
Okay, meanwhile, I can show them a picture of little cart.
Little cart
I share-
on
Oh, sure,
the,
sure.
the wall structure is about 3 kilograms.
the
3
total
kilograms.
weight of the prototype. Of the structure.
This part and prototype. But lithium battery, about a minute finish, stop. Not
Yeah.
are able to have long duration.
And yes, they deplete
Battery has
quite
a
fast.
short lasting batteries.
And about 60 seconds, if I'm not wrong.
Oh, so he's saying it's self-contained.
The problem to say, to show all. Moment. These are ferrites. Ferrites.
Ferrite.
All right.
This is another ferrite of megahertz. This. They're in the prototype. These are about 15 centimeter. You can see.
Yes, so about 15 centimeter, I believe. You said.
You can see this. This is a piece of Lutz wire. 600 wires, 600. To have a maximum current. Current is a fundamental
Is
for
that
every
solid or solid?
force. You must soldare.
Solder. You have to solder.
And then cut ferrites you need.
And there is the need to adapt all the materials to the to create the dipole. The ferrites are not of the right length. They are not the right.
Non mi viene più. Scusate.
Well, Emilio, thank you for sharing it. Thank you for sharing that with us.
Good evening to all.
Is it stranded or solid wire
Oh,
in
okay.
the vertex?
There we go.
Can you repeat, please?
Is the wire, okay, you have these two wires coming like this. Okay, these two wires, are they stranded or solid?
What is this?
It looks like that's stranded. I
Looks
believe you
like
said
a
it was
stranded wire.
600 strands.
600 wires.
Okay,
Thin
600 strands.
110 millimeters.
Okay, very good. That's what's my question. Okay, and the frequency, what was the frequency? 432 megahertz, correct?
Yes, yes, please.
Okay,
Not never magnetism, never. UHF with UHF
UHF.
megahertz.
UHF
Never,
current.
because magnetism, never.
so the ferrite,
Never.
is that like a shield or a choke for the RF somehow? You know, like when you buy a choke for you know, the little ferrite coils that you buy. It's a little circle ring, and you put it in the wire, and it takes out the RF signal. It takes out the RF noise when you put this around like a wire. You know what I'm talking about? It's called an RF choke.
On my opinion, one will be convinced if repeat the experiment. Only repeat the experiment with patience. You can say all, but you need to try to repeat the experiment, because we have now another type of physics. If we third principle of Newton is violated, change the second principle. Is not the same, can't be the same mathematically. So another physics, you must study another physics, and many experiments.
Well, I think we all want to do that.
Do it. I can see more. I can see more.
empathize with you.
Yeah. Well,
You must
so
do.
let me
Change inertia principle. The same.
So I got this book I wanted to share, which I think has a lot to do with what we're talking about here. It's about metamaterials, and that figure you're showing me. And so my question was, it describes what's called a thin wire epsilon negative metamaterial. And this is what it has written. It says,
Zanotti, digli che non capisco quello che dice. Zanotti, digli che non capisco quello
Sorry,
che
Michael, he doesn't understand
yeah.
what you're trying to say.
Michael, that might be better. That might be better to email actually.
Yes.
okay, certainly. Would you post your email in the chat, please?
Yes, I will copy
Zanotti.
that.
Okay, very good. Thank you.
Zanotti.
Yes.
It's just a comment. I'm intrigued by what your results are. I'm just trying to figure out why. It's just natural. We like to do that. So
yeah. Well, thank you, Michael. So let me go to Harold Tavares, who's been patiently waiting. Harold, would you like to go, sir?
Yes, I have a question. Is why the 28-degree angle? Have you done other tests at different angles, and why that one is the one you chose to produce the Lorentz force that created the thrust?
The basis is to violate third principle. The first is violare il terzo principio. Dopo mantenere la spinta nel tempo, perché solo se uno mantiene la spinta nel tempo esce fuori un cambiamento del secondo principio.
Translate, Sergio.
Yes, no, Emilio.
Second principle. It is PNN is a artificial procedure. Is not natural. Is not natural. Don't exist in nature. So as a radio don't exist, and a television don't exist. So don't fix PNN naturally.
Okay, well,
You need to enter another type.
Emilio, hold on for a moment, because Sergio is trying to
Excuse me, but I don't
parlare
understand.
Sergio, Emilio.
He's trying to translate for us, sir.
Yes, no, sorry, I talk a moment in Italian to Emilio. Emilio, Harold stava chiedendo perché l'angolo di 28 gradi, se ci sono altri angoli che si possono usare.
Tutti in teoria sono possibili tutti, dipende from impedance. Impedance, matching impedance is very important.
Okay,
and
Harold,
I see trust when at 90 gradi, 90 degree, I see. So I see when angle is about 7 degree. So the very important problem is that mismatch of the line that destroy amplifier. So you need direct energy, reflected energy elsewhere. You must power effect must go elsewhere. If so is not so, amplifier is destroyed. Hanno capito, Zanotti?
I don't know. So the question, Harold, was to answer your question, Harold, the angle can be anything.
28 degrees.
Any degrees, yes. There are different shapes that can be experimented with the PMN. So the dipole is the basic one, but there are many.
Yeah, my final question is radiation taken into account as producing thrust of the part of the Lorentz forces?
Radiation?
The radiation produced, the V-shape produces radiation. What is doing the Lorentz thrust? Is the radiation produce part of the thrust or zero?
No, the complete thrust, all the thrust is achieved with Lorentz forces.
100% Lorentz force, no radiation.
I think 100%, yes.
Where does the reaction go?
This is a good question. Yes, it appears to not be present. This is what we have observed so far.
Okay, because the reason I asked that question, September 6, 1952, in Nature, there's an article that is electromagnetic momentum and Newton's third law, in which they say that when you are producing reaction thrust, if you take into account the radiation produced, for example, during the Lorentz forces, then you can say, that energy conservation momentum is conserved because part of the thrust being produced by radiation. And that's why I'm asking, since machine is producing radiation, is that radiation producing the thrust or part of the thrust, even though the Lorentz force is the one getting the credit for all the thrust?
I forward this question to Emilio, but I think 100% trust. Just a second. Emilio.
Che cosa?
Sì, chiedeva Harold se tutta la spinta è prodotta da Lorentz oppure anche dalla radiazione del dipolo.
Che cosa hai detto?
Tutta la spinta è prodotta dal dipolo, dalle forze di Lorentz, o c'è anche qualcosa?
Solo forse è la risultante di due forze di Lorentz sui bracci.
Okay, so Harold,
La regola del parallelogramma rule.
Okay,
So,
it's only
it
the
is,
Lorentz forces, Harold.
So forces, and then resulting. Digli che è violata pure i collider, la quantità di modulo. Momentum, collider in collider.
Mm-hmm.
Thank you.
Zanotti.
Okay, and thank you as well, Harold. And Sergio, I should ask, are you doing okay? I'm worried that we might be exhausting you because we have so much back and forth in language translation.
Oh, well, for the moment I can manage it.
Okay.
Thank you.
I just wanted, I wanted to check. I wanted to check because I know that you're right in the middle of everything, and I appreciate your efforts.
Thank you.
Let me see. Who should we go to for questions? Who would like to go next? Actually, there's a ton of stuff in chat. Maybe I should bring Remy. You had several questions and comments. Would you like to come on?
First of all, just thank you very much.
Oh, sure. And Remy, could I get you to enable your camera, if that's okay?
Oh, you don't want to see me.
Oh, okay.
I want to see him.
No. Anyway, seriously, thank you very much for the presentation. You've done some good work there, and I think there might be something there. What it's saying that the usual disproof for Lorentz forces is you take it around a loop, and with an antenna is not really, how would you identify a loop unless it's a displacement current? So he's got two arms. They've got two arms of the antenna reacting against each other, and you get this resultant force. I think there might be something there. And the thing is, Harold was saying, how does momentum balance? You know, he's saying this Nature paper from '56 saying that it would be taken up by the radiation reaction. It's a very small force. It may be something that you can directly push against the 0 point, and that would explain the momentum balance. So I just keep an open mind. I mean, you guys, you carry on what you're doing. I mean, you're doing brilliantly, you know? So, I mean, on that basis, I mean, it's good to see people making the effort. And yeah, I think you might have something there. That's just my belief. Yep.
To read this part. Okay, in the magnetic interaction between two electric wires in which the current flows, there is a factor of 4 pi Greek for 10 to -7. This is the force, the actual Lorentz force in two parallel wires with direct current. This force is very negligible. We need to amplify this force, and the trick is to amplify this force through the ferrites and through this dipole, through the PLN thruster, so through the field interaction and the ferrites all around the wires.
Okay. Who would like to go next? Let me see. So we just went to Harold. We went to Remy. Let me see. Michael Boyd, did you have more questions, sir, or were you set for now?
I just wanted to say I posted in the chat a link to Amazon for the book that I told you about, and I also sent it to the email address that I was given, and just also wanted to thank Michael Hines. He's the one who turned me on to this book, and it's pretty good. So, and what I like about it is it does metamaterials from both what I would call dielectric planes and then also transmission waves, like, and if you're doing experiments with RF, I'd recommend you get this book too, because it has some important information about harmonics, conjugate waves, that kind of stuff, which are, I think, important to understanding space-time modification. So in any case, thanks. That's all I just wanted to share that.
Okay, well, thank you.
But I think it's pertinent to what he's doing. I think that's what he's doing is described in there.
Oh yeah. And I'm sorry. I'm not trying to sound dismissive at all.
No, you don't.
Okay. So let me jump around here. Let me see. Did anyone else have questions?
Yes, Harold, again, one question. I want to ask him if he have used pulsating DC for that experiment to see if it produced any Lorentz forces and thrust instead of AC.
No, this works only with the AC. I can share you a video where Emilio explained the whole principle of PNN. Just wait a second, please. Okay, this one.
Excellent.
So this is the start for PNN thrust.
Simple explanation.
So in this case, with a continuous current, we have 3 Lorentz forces. And the trick with the PNN is to remove one side of the circuit. So now the forces are only 2. And by applying the parallelogram law, the resultant force is a forward thrust. Yes, this is the problem. The forces are very weak, let's say in nature, let me say. I hope you could see the subtitles. I hope you understood.
I just wanted to thank you for coming on. I've been interested in Emidio's research ever since I first heard about him, and it's nice to get you on here.
Thank you, Jeremy. And you're welcome.
Thank you as well. I think that is it for right now. So why don't we do this then? I want to put this back on gallery mode. Everyone, please put your hands together once again for Sergio and Gabriel and Emidio as well. Gentlemen, thank you very, very much for joining us today. I sincerely appreciate it. And I know that the language barrier made things difficult, but I sincerely appreciate your
Thank you very much. I'm glad you appreciate it.
Thank you for your time.
Thank you.
Thank you very much.